Hey everybody, Mr. Munson. I'm glad you're here. Let's take a look in this video at the concept of domain and range. Pretty important topic. We use it quite a bit when we're dealing with functions and graphing. Let's start with making sure that we understand the basics of what the word domain and range means. Domain represents the x's that we're allowed to use and possibly use in our equation. Usually we're looking at the real numbers or whatever, but there could be some kind of restriction on that. For instance, suppose I had an x that if I plugged it into a particular type of equation, it made the denominator go to 0. We're not allowed to divide by 0, so that would put a restriction on the domain. The range represents the products, the y's that are coming out. And so there could be restrictions on the range. It doesn't cover all the real numbers. There could be restrictions on that. And so let's just kind of pause for a second and move over to these graphs here and see what we, make sure that we understand the idea of domain and range. So if you take a look at the top one there, that is a classic parabola, a quadratic. It comes from the parent graph of x squared. It's basically a U-shaped graph. It comes down, hits that 2, 0, 2 is the minimum there. Comes down, hits that, and takes off again. And so the domain of this, the x's that I'm allowed to put in it, would be easily seen that with using a vertical line, I can just kind of move it along and look and see, is there any place that that graph does not produce a y output for that x? Does it just not exist? And so I can move that line anywhere along that graph, and of course the graph continues up in both directions. It's there available to be a relationship for every x I put in. There's no restriction on my x. So that would be all real numbers. However, my range is restricted. I definitely could have numbers higher than what I see as that 2 is the lowest of the y's. But I will never be able to find an x that I can put in there that will create a number lower than 2. Now, taking a look at this graph, we have again a graph that if I run a vertical line through it, I can create relationships between every x. You know, if I have an x here, there's a relationship that goes with that equation with that y. But if I come over here, you'll see that there is no relationship that the x's over here in this far negative region has with this equation g of x. And so there's a restriction on the x's that I could use. They don't create any y's. Same thing is true for the outputs, the range. There's a restriction on the range. I can't possibly get any deeper x's here or deeper negative y's. No matter where I go on the x range or x domain, there's no y that will be down in this region. It stops right here and continues at that point. I can have any positive y I want, but there's a restriction on the negatives. So how do we express that in written form? So let's take a look at that. All right, well, let's take a look at this problem. We have some function here. It has a limited domain and it also has a limited range. And so how would we express that? We certainly could do it in set notation like that, and we could represent it in interval notation like that. They both mean the exact same thing. This is read as like x is a member of this group, this set, such that x has to be greater than 1. The inputs have to be numbers greater than 1. Now, why that's happening on this graph, I don't know. I don't have the equation, but maybe something happens with the equation with negative numbers, or maybe in real life in the sense of it never has numbers less than 1. The range, as you can see, the range, it's here, the highest it will go is 3, and then it's all these negative numbers down here. It's possible. And so y is a member of the set such that it's trapped between the lower end of negative infinity and the upper end of 3, and it's inclusive. Okay? Now what I want to point out is that you'll notice that y is trapped between these. We always write the lower end here and the higher end here. Looking at the domain and range written in interval notation, again, the domain is the x values. Yes, I have x inclusive. It's colored in. I'm allowed to use the 1. And I can use any x going up larger all the way up to infinity, the graph continues on. And then the range, of course, is allowed, I can get negative infinity numbers all the way up to and including 3. So that's the notation for those two. Let's take a look at another one. Okay, so let's take a look at this one. I have a function here that has some gap that's going on in it. And so how do we represent that? So I have a set builder notation here as well as interval notation. So let's see how this works. So x is such that it has to be less than -1. So if I'm looking at my graph here, I can see here's -1. And so the x's I'm allowed to use are less than -1. And then x has to be greater than 3 in order to be a part of this equation or allowed to be an input for this equation. There's no relationships for the numbers between 1 and 3. Now, for the range, if you look at the range, a lot of times students will, because of this gap, think there's a gap in the range as well. But if you look at it, if I take a horizontal line and run it along here, you can see I have a y here, a y here, a y here. I have y's for every place I go, including where this gap kind of seems to happen, right? That's 3 there. So, and the graph continues up. So in reality, my y is an element of all the reals, right? So I can get everything out of this no matter what x's I'm using. There is a y output for every number on the y-axis. And then the interval notation here is written, you know, the interval in which I can use x's go from -1 all the way down to -infinity. And so that's inclusive there with the -1. Or I can use x's that are greater than 3 and going up to infinity. And then the domain, as I said, is all reals, and that's how we always write that. Okay, let's do another one. All right, let's take a look at this one, but you're going to take a look at it after you make your attempt at writing the domain and range and the two forms, the set builder notation and then also with interval notation. So I've got an interesting graph there. Part of it is just being able to decipher what's going on. In a problem like this, you got a lot of stuff going on. And so just take your time and see if you can come up with the domain and range. This one's going to be in the set builder notation form, and this one's going to be an interval. So go ahead and put me on pause and see how you do. All right, welcome back. So we have the domain and range written in two different notation styles. So yours should be very close to this. The domain written in set builder notation is x is such that it's a member of all the reals. And the range is such that it's greater than or equal to -5. So I can get y's that are greater than -5, but nothing less than that. And then in the interval notation, this will always mean all reals. So if you have all reals as a set of domain or range, you just use this notation. And then this would be the range written in interval notation, meaning that it's inclusive of -5 and it can go as high as infinity. All right, let's look at something else. All right, so sometimes we're going to run into the circumstance where we want to write the domain and range given the equation like this and we don't have the graph. Now we could certainly go to a graphing tool like we've done in the past and graph it and come up with a domain and range, but maybe it's just the domain we need, and that's an easy task now. It would be a lot more work to go do it on a graphing tool, okay? So what I want to do is I want to create just the domain restrictions that come with each one of these. So what I'm going to do is I'm going to look at f of x and realize that whenever I have an equation like this or a function where it has a denominator, I can't allow the denominator to go to 0. And sometimes that possibility exists, sometimes it doesn't. You know, if I had an equation like this, there's no way for the denominator to go to 0, so there's really no restrictions. The domain of this would be all reals. So looking at this one, what I want to do is realize that it's the denominator that's at risk of causing problems. So I'm going to go find what x's make that thing become a problem, and it's when x is such a number, when I plug it in, it becomes a 0. Let's do that work right here. So if I plug in a 5/2 into 2x minus 5, it will cause that to go to 0, and my function will go crazy. It doesn't like to divide by 0, of course. So there's my restriction on my domain. Let's go ahead and write that up. So if I was just looking for my domain, it is x such that it's a member of all reals or a member of the real set. And I have to have the restriction on it that x can't equal 5/2. Now let's take a look at this one. Let me erase this. Let's look at this one. What's the restriction on this? What's going to be the problem? It's not that the denominator is going to go 0. So what I want you to do is put me on pause, and either you know what the problem is here and you can go find out what the problem is doing it mathematically, or I would like to encourage you to go find another place on the internet. We live in a wonderful time where a lot of these questions can be easily asked. Go research what is the problem with radicals that we would have a restriction on it. Do the work, come back and check your work. Okay, put me on pause. I'll see you in just a minute. All right, welcome back. So in this function g of x, what we find is the radical can't go to a negative number. Otherwise, we're dealing with imaginary numbers. Now, this is true for anything that has an even nth degree. So we can't have this go negative for square roots, or if it's a fourth root or sixth root or anything like that. It's no problem if it's odd. If you think about it, see, the problem is that if it's an even root and it's -4, let's say, an even root says, what do I multiply times itself? 2 times, in order to get -4. Well, it can't be 2, because 2 times 2 is 4, and that's not -4. And sometimes students will think -2, but -2 times -2 is +4, because negative times negative. So the problem is that we can't have, in the real numbers, a negative number underneath the radical when it's an even nth root. But if it's an odd nth root, there's no problem with that. Think about it. If I'm looking at the cube root of -27, that's possible. Think about it. A negative times a negative times a negative will give me a negative number. So that actually will work, right? And by the way, in case you were wondering, the answer to that is -3. Okay, back to this. So I set up my restriction inequality to find out what it is that would allow the x's to make sure that the zeros always, or the x's is always staying at 0 or above. So I solved it. And here's my restriction on my domain. X is such that it is greater than 7/5. Anything less than 7/5, this thing goes into the negative region underneath the radical, and the equation stops. Okay? Okay, well, I hope that was helpful, and domain and range. So we'll see you next time.